Hi guys, my name is Carlos and in this video I'm going to show you how to create a regression machine learning model using the designer in the Azure Machine Learning Studio. The designer is a simple drag and drop tool that you can use with no coding experience to create models. First, I need to create the Azure Machine Learning resource. I'm going to type machine learning. I'm going to select the resource and I'm going to create a new one. I need to specify the expression. I need to create a new resource group. I'm going to name it Carlos Machine Learning. I'm going to create a workspace name and I'm going to create a new container register. I'm going to name it Carlos Machine. Okay. I'm going to hit review and create. And finally I'm going to hit and create. We need to wait for the workspace to be created.
After it finish, you are going to go to the resource and you need to launch the studio. The first thing that you need to do is to create the compute targets in which you are going to run your models and deploy them. So you need to go to the compute level. Here, the first you're going to create the compute instance. We need to name it. We're going to select the DS11 B2. Something is wrong. Here we go. I'm going to select the cheaper one. I'm going to name it. This name is okay. The location is going to be the same as the resource group. I'm going to create finally the resource. I'm going to create the compute cluster 2. You need to hit the new button, and here you're going to specify the region. It's going to be the dedicated virtual machine tier, the CPU virtual machine type, and here I'm going to select the cheaper one. I'm going to hit next. I'm going to specify two numbers of nodes. I'm going to put the name. I'm going to hit create. I'm going to pause the video until it finishes. Then you are going to hit the designer level. Here, as I say in the beginning, is the drag and drop tool that allow you to create the model without coding. First, I'm going to add the sample dataset. I'm going to add the automobile press data. I can name the pipeline with the name that I want. I'm going to put the name as auto price training. One important thing is that you need to specify in the settings the compute instance that you are going to use. So here I'm going to select the cluster, the compute cluster, and I'm going to select the compute that I just created at the beginning. Okay. Okay, here in the automobile press data you can see in the outputs the preview of the database. Here you can see in the last column the price column, which is the column that we want our model to predict. Here you can see various data relation to every column of the database. You can see there are some columns that have missing values. Let me show you like this one, normalized loss. This is the reason that we need to create the cleaning data process to clean the data for this database. We need to normalize the data too, so our model can work properly. So in order to do that, I'm going to drag one data transformation block. It's going to be this. In order to clean missing the data, first we need to select the columns that we want to process. So I'm going to select this block, and I'm going to first connect the output of the automobile price data to the input of this select column in datasets block. So here I'm going to edit the column. I'm going to select by name, and I'm going to select all the columns except normalize losses. So I'm going to add all, and I'm going to remove normalize loss. I'm going to hit save, and I'm going to drag and drop the clean missing data. Is right over there. I'm going to connect the output to the input, and I'm going to drag the normalized data too. Here you go. And I'm going to connect the left output of the clean missing data to the input of the normalized data. So here in the clean missing data we are going to specify the bore, the stroke, and the horsepower column to be processed. I'm going to hit save, and here we are going to specify the required arguments to clean these columns. So first, the minimum missing value ratio is going to be 0, and the maximum missing value ratio is going to be 1.0. I'm going to remove the entire row that has a missing value in these columns. Everything is okay, and I'm going to edit the normalize block. So here I'm going to apply the min max method for normalize these columns, and I'm going to select the columns. I'm going to select with rules, and I'm going to select all the columns. And I click and save, and I'm to test it. I'm going to submit the pipeline. I'm going to name it as MS Learn Auto Training. I hit submit, and we need to wait for the result. It's running. You can see here that it's going to, in this block, select column in datasets. So we need to wait for it finish. It's done. You can see here that all is in green. You can check the result of the normalized data. If you go to the outputs and log levels, you can preview the data. If you hit in the preview data in the transformer data set, so here you can check that we delete the column that has the most missing values, and you can see that the rows that have missing values were deleted. You can see too that we have normalized all the numeric values that we specified. The next thing that we're going to do is to split our data set in order to obtain the testing, the training and validation sets. Then we need to add the train model. We're going to connect. I'm going to modify this later. First, I'm going to connect all. It's going to be to the right input, and for the left input, I'm going to specify the model, the type of the author model that we're going to create. This is going to be the linear regression. So I'm going to connect to the left input, and then finally we need the score model, and I'm going to connect here. This model is going to use the right output of the split model to the right input in the score model. So first, in the split model, we're going to specify 70% for training and 30% for validation. This stratified split option is going to be used for the classification type of models. So here, as we are in the regression type of model, we don't need it, so it's going to be false. I'm going to specify for the random seed 1, 2, 3. Everything is okay here with the split model. In the train model, we just need to define or to select the column that we want to predict. In this case, it's going to be the price column. So here I'm going to select the price column. That's all. And finally, the score model is going to test the train model. We need to use it to score the validation dataset we held back when we split the original data. I'm going to hit in submit, as it is. I'm going to hit submit again, and this is going to start from where it left. So we are going to wait a few minutes for the result. So after it finishes, in order to evaluate our model, we need to drag the evaluate model block and connect the output of the score model to the input of the evaluate model. We are going to hit submit again, and we are going to see the performance metric of this regression model. This won't take long because this is going to resume for the last round. Here you can see the result of the evaluate model in the outputs and logs. You can check in the preview data, and here you can see the mean absolute error, the root mean square error, and the other metrics for our model. The next thing that I'm going to do is to create an inference pipeline. For that, you need to click here in the real-time inference pipeline. It's going to take a while. This is for the deployment purpose. But first, we need to modify this inference pipeline. First, we need to remove the automobile press data because we are going to run this with a new data that is going to provide here for the web service input. So first we need to remove this block, and because we don't need to evaluate more the model, I'm going to delete the evaluate model. Okay. I'm going to add the enter data manually block. I'm going to specify three cars that don't have the level of the price in order to predict that column. So here I'm going to connect to the same input. I'm going to modify the select columns in datasets. So here we need to remove the price column because the new data that is going to arrive doesn't have the price column. So here we are going to remove, we are going to save. Another modification that we need to do is between the score model and the web service output. This model, the score model, includes all of the input features as well as the predicted level. To modify the output to include only the prediction, we need to delete this connection. We need to add and execute Python script between the score model and the web service output. of the score model to the left input of the Python script and the left output to the input of the web service. Here in the Python script we are going to replace all the default code with this one. This is going to select only the score levels column and rename it to predicted levels. You can see here predicted price. Sorry, I'm going to hit so finally we're going to submit. We're going to name it as MS Learn Auto Inference. I'm going to hit submit and I'm going to wait until it finishes. Finally, you can click here after it finishes in the execute Python script, and you can see here in the outputs and logs the resulting dataset, the preview data. You can check the predicted price for the 3 cars that we submitted in the enter data manually block. So I leave it the deploy for you. I hope you are okay. I see you in the next video. Bye bye.